pollution has increased during the last 7-8 years. Last time it has been done in 2010. So just a brief of that, and after that I'll come to the main. Next. Sorry. So this is the area where the emission inventory is developed. This is the national NCT region, and this is the region which is about 70 to 75 kilometer region where the emission inventory with 400 meter by 400 meter resolutions were done. And then something about 26 different sectors were counted, which all of you know, that transport sector and the biofuel sector and so many other sectors. But this is one of the sectors which is surprising to us also, that in outskirts of Delhi, in the big kiln, this is the fuel which is used heavily. So this is all nothing but your shoes. And because that lasts for 7-8 days, and they need, each bhatti needs that kind of a sustained kind of thing. If you put it some other fuel, it will be finished, and then the consumption is more and then cheaper in this. So this is just, and the same as exact technology it is being used. So this is rampant. Now, yeah. So this is the latest satellite, our own satellite image, where land use and land cover changes in 2018, and this is what is very important, which we got it. With this we will know that what is the wind blown dust, where the water body is, where the construction activities and all, which is a very high resolution. And this has helped us in something like about 8-9 sectors: agriculture and build up land, build up area, high rise buildings and all. This makes us to develop these emission inventories. And with this, the kind of a summary of this emission inventory, not going too much in detail, is that the transport sector is about 40% contribution in total emissions, which is a increase about 40% increase from 2010. The industrial sector is increase about 48% from 2010 to 2011. But you will see the residential sector, it is about 6%, but there is a decline by minus 64%, mainly because of the fact that in 2010, about 40% of the slum areas in Delhi were using LPG, but now it is 95% of the people are using LPG. So that's the thing. Then suspended dust has declined again by 26%, and then the summary of that these are the two sectors where there is a decline, whereas so major sector industries and all, this is what is making, so this is going to help in a very big way, in a sense that in a mitigation measures, and this is 400 meter by 400 meter in 70 by 65 kilometer region. So that makes a lot of. Now coming to this, this is one of, I will go in very fast in this. This is one of the complicated, that from the global we come to the local scale where these emission inventories are being put. These are the species and these are the inputs we take it, and then, and you will see that these are the potential dust sources. So now we have put dust module also. So the Gulf dust, which was covered and given the extreme events in Delhi in 2018 beginning, as well as in June this year, this has now been simulated. Earlier we were not able to do that, but now with a lot of schemes and all, we could do this, and then 2008 we were able to do that. We could not do it in 2017. Okay, so this is something where one of the simulations, that from where, how from the Gulf this is dust is generated. This is dust generated and goes into Rajasthan area. Rajasthan, it picks up again. You see the darker area because there is already in May, June this was, and then whole Indo-Gangetic Plain region in Delhi, how does it covers. So this is one of those important simulations we could be able to do that. Now, so this is the way. There are different schemes with the go-kart scheme, these are more sensitivity tests. In our research mode, we keep on doing it. But these are the PM 2.5, PM 10 concentration, which has been derived with this. These were the methodology. Okay, now coming to this, this is one of those important things that this time stable burning contribution we could able to bifurcate from the total emission in Delhi. What is the contribution from Punjab and Haryana stable burning? Earlier, what used to be there used to be a fin emission from the Modi's data. And they gives only the light counts. Light count with the false alarms also. Because if Deepavali day is there, light count will be 3-4 times more, and we will be still considering is there stubble burning or something else. So all those things. So this time our own inset 3D data, Modi's data, as well as the real story which is there now being compiled in CPCB and DPCC. Keeping that in mind, we could define the burning fields, and you will see that with this, this is something on a particular day, that these are the emission on 16th of November, 68 gigagram per year Kharif fasal, which is going to see the Delhi. So this is the all Punjab and Haryana, and these are the fields where on a particular day. So this is the dynamic emission inventory. Every day it has been done and then put it and then simulated those values. So now how we did it, this is one example of Punjab, where you will see the blue dates where it is there. These are the fields which are vulnerable to burning, and remaining are residential areas and all. So now every day, which field is being burned, that is how this being put over there with these three combination and then this thing. And keeping that all in mind, whole of these seasons, we could see that how much is the contribution in Delhi's PM 2.5 is coming in the different days. So it can go up to as high as 40%. But then the take home message here is that even if the fire counts is extremely high over there in Punjab, it's not necessary that it is going to influence Delhi. It all depends on the upper wind direction, speed, and number of meteorological factors. So meteorology is a key factor again deciding on that. So this is something, message which need to be taken. And last 3-4 slides are, this is based on aerosol study. We did it over Satopans Glacier in Western Himalayas, where with the Garhwal University, and we have a MOU, and with this we did it. And there was something very important, that this is the glacier location, where these are the study which we did it. It is just a couple of months back. And then here this is just only literature to show you that how Himalayan region is made a strongest positive trend in May, resulting in statistically significant warming. And because, so this is an introductory slide, but then coming to the results are that these are the observations we took it, athylometer, number of, because these are the campaign which has been done during this period, and then opaque, and then model being used May to October 2018. And then earlier we did it in September, October, that one, but this is the latest. So I will be making a result for this. This is one of those examples where the BC daily average time series in 2018, although the compared to Delhi and other places is very less, but you'll see there is a good amount of, this is in nanogram, it's not in a microgram. So this is BC black carbon. Then how in a month wise, in a monthly average, landed variation in this Himalayan regions are that in BC, you will see that highest get into July month, the concentration, and the lowest get into October. So as the winter sets in, it starts declining, and this is the diurnal variability from 10 o'clock to 1 o'clock. So how the diurnal variabilities are, it has a different mechanism, physics behind it, that how it is. But then important take home message is that the concentration, how in the monsoon time when it gets into this thing. These are the monthly ranked black carbon. But now with this kind of a thing what we are having, we can bifurcate that what could be attributed to biomass burning, which is getting transported. So this is the BC month wise, and these are the contribution over the glacier due to biomass burning. You will see these are the contribution of that. So total with this, so biomass contribution could be as high as 20, 30, 40%. But this is, I'm not talking about stable biomass. This is the biomass which we are talking about. In general, long range transport, that it comes. And then what are the chemical compositions in terms of giving rise to the health impact as well as the radiative forcing. And these are the things in a glacier. These are the contribution that, so major thing what is important, calcium is still very high and sulfates are also very high. These are the two things in the glacier. And when you see in a chemical composition is like snow, then you will see again glacier, but the sulfates has reduced, but calcium has increased. And then second thing comes out to be something like potassium and sodium. And